Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I will go through these end of year examinations for the year 9 pure chemistry, triple sciences that I'm teaching at the moment. So the topics included in these particular end of year assessment include the stats of matter, which is to do with kinetic particle theory. And then we also have atomic structure, so counting the protons, electrons, and neutrons. We have bonding, we have chemical formula and equations, so those are to do with mole concept. And last but not least, we also have experimental techniques as well as qualitative analysis, so QA. So these are around 1/3, around 33% of a year 9 curriculum. This is a 3-year curriculum, and as such, the contents are a bit lesser than in a 2-year curriculum. The contents within are entirely suitable for any 14 to 16 years old students doing the triple sciences, the pure chemistry, IGCSE, GCSE, or the O-level curriculum. In this first question, so these scientists needed to add approximately 100 cm³ of water. This idea here is approximately 100 cm³ of water, so not very accurate. If the scientists wanted to be very accurate, the scientists would have said to add exactly like 100.0 or 100.00. You have each of the 50 large beakers. The idea is as quickly as possible, and the idea is also approximately. So not going to be a burette, so this is time consuming, and also that is really accurate, but that is not really needed here because of the terms approximately as well as quickly as possible. So not going to be a gas syringe, as this is solution, and we are not talking about, well, this is solution, essentially is water. Not even a solution, it's just water. So not going to be a gas there, neither will it be a pipette. It's got to be a measuring cylinder that is, going to be pretty much accurate, and you just pour each and every 100 cm³ into each of the large beaker, and they'll be pretty quick there. Question 2, you have 4 mixtures, you have 2 substances, you need to be separated and collected, the 2 substances. So you cannot just collect one substance. It says the 2 substances need to be separated, the 2 substances need to be collected. Now, copper 2 sulfate and water. So copper 2 sulfate is going to be an ionic compound. It has a giant ionic structure, so it's a solid at room temperature and pressure. This is a simple covalent molecule, so it has a simple covalent structure. We don't talk about chromatography because copper 2 sulfate dissolved in water. Water itself is just water, usually as a solvent. Chromatography works based on different solubility in the solvent. Okay, so different solubility in the solvent. This is not going to be suitable method to separate copper 2 sulfate from water. Methanol and ethanol, so these are families of alcohol. These have different boiling point, and evaporation is not going to be a good way. We should have done a fractional distillation, because you have 2 components that you want to separate out there, so not good there. Oxygen and nitrogen, fractional distillation of liquid A, that is entirely suitable because nitrogen and oxygen would have different boiling point. That is the key criteria that will make it suitable for any form of distillation. So sand and barium sulfate, sand is insoluble in water. And we also have barium sulfate. You have a white PPT. This is about solubility rules as stated in the syllabus. Solubility of sulfate. All sulfates are soluble except for barium sulfate, calcium sulfate, and lead 2 sulfate. So not going to be able to separate by filtration. That's a C is the best answer. Question 3. So we have a colorless solution, and we tested with aqueous sodium hydroxide and aqueous ammonia. So these are basically tests for cations, positive ions. These are results from the qualitative analysis table. Results are given, the table of results are given in paper 3, practical, paper 4, alternative to practical for the new syllabus coming out in 2023. However, in theory paper 1 and paper 2, this table of results will never ever be given or provided. So you have a white precipitate with 2 drops. So this is just a little bit, that is usually what we do when we do practicals involving tests for ions, we add a little bit, and then we add in excess. So what happened? This precipitate dissolve meaning it is soluble in excess, sodium hydroxide. When we look at the table, we always think about excess of what, because just because you say soluble in excess, it doesn't have a meaning unless you know soluble in excess of what. These are tests for cations, so these are anions, therefore they are not applicable. These are not tests for anion. If you want to test for chloride, you need to add some nitric acid, and then you add the silver nitrate, aqueous solution. Usually they use word. I'm just using chemical formula here because I can't, but usually we use word, add nitric acid, then add aqueous nitrate solution, and you will get a white PPT due to the precipitation of silver chloride, year 9 ionic equation, and also in solubility rules of chloride, and also in the test for chloride, paper 3 practical, as well as paper 4 alternative to practical, test for ions. So A and B are tests for anion, these are tests for cations. So between the two cations, Al3 plus and Zn2 plus, the only difference is with aqueous ammonia, because both of them will produce white precipitate. In sodium hydroxide, the aluminium hydroxide and zinc hydroxide would dissolve in excess of sodium hydroxide, which is a strong base, strong alkali. Whereas when you have excess of ammonia, this is a weak base. You will learn more about these in year 10, acid, bases, and salt. But only the zinc hydroxide is soluble. So we can see that this precipitate dissolved in excess of NH3 has got to be zinc 2 plus and not Al3 plus. Question 4, what happens when a substance freezes? So freezing is to do with liquid going to solid. We think about our cooling curve. So in the syllabus, we know about temperature against time. We know that cooling curve is kind of like the opposite sense of heating curve, because the temperature keep on decreasing. So when the temperature decreases, we are cooling them down. But we have this point here. This is gas going to liquid. So that would be your condensation point, which is the same as your boiling point. Whereas you also have the freezing point, which is the same as your melting point, because whether you're going from solid to liquid going to solid, they will both happen at the same temperature. When the temperature remains constant, we know kinetic particle theory said that when the temperature remains constant, it will not move faster, it will not move slower, because no change in temperature. If temperature is constant, then no change in kinetic energy, therefore no change in your speed of the particle. Instead, during melting or during boiling, the particles move further apart, but during condensation, during freezing, the particles get closer together. So they will definitely become more ordered as you're going from liquid going to solid, not less ordered. So C and D are out already. Particles gain energy, that is not going to be correct, because when you go from solid to liquid, you need to put in energy to melt, you need to put in energy to boil. Energy is needed to break something, and that something depends on your structure. What bond do you need to break? That depends on your structure. This is to do with freezing. It's the opposite of melting. Melting, the particles will gain energy that you break the bonds, but particles lose energy when you freeze, because it's the opposite sense there. Question number 5, you have ethyl amine, which is not ammonia. So we cannot always assume it is ammonia. The question very clearly gives you the formula. So the first thing we do is find the MR of C2H5NH2. Calculating MR is based on the relative atomic mass in the periodic table. So you have 2 times 12 plus 5 times 1 for the 5 hydrogens. In fact, you have 7 hydrogen, 5 and 2. So I'm just going to do 7 times 1 for the 7 hydrogen. And then I have 14 times 1, which is going to be the 1 nitrogen. So 2 times 12 plus 7 plus 14, I get 45. And I'm going to compare this with the MR of HCl, which is 1 plus 35.5, that's 36.5. So this one is lighter. If it is lighter, it will diffuse faster. So rate of diffusion is to do with your mass as well as temperature, but these are at the same temperature. So the lighter the mass, the lighter the MR, the faster it will diffuse, the longer the distance it will travel. I think B is the specific midpoint, and you will be at B if your MR is the same, so B is wrong. It will not be as C or D because unlike ammonia, this is heavier than this, therefore it's the HCl that will move further closer to the ethylamine, leaving the only answer as A there. Question 6, what we have is this particle. So whenever you encounter questions like this, we always have to read the question carefully, and we have to think about our protons, neutrons, as well as electrons. We do it even the question doesn't ask us to, because we know it's to do with counting protons, and then we count the electrons. Electrons, these are not atoms, these are ions. Positive ions means that you have lost electrons. In the atom, you will have 26 electrons, same as 26 protons, because atoms are uncharged. So this is 26 minus 2, giving you 24 electrons. This is 27 minus 3, giving you 24 electrons. And I'm just going to continue further, and this is to do with the neutrons. So we have the nucleon number on top. So this 54 is what you call the nucleon number, which is the same as the mass number. So that is the number of neutrons plus the number of protons, whereas the 26 at the bottom, that is just your proton number, or your atomic number. There's just your number of protons there in the nucleus of an atom. Take away the 2. The bigger on the top left minus the smaller at the bottom left. These are international standard notation stated in the syllabus. So 54 minus 26. Do that on your calculator and you get 28 neutrons. 59 minus 27 and you get 32 neutrons. So what is correct? What is correct about this statement? Same number of electrons. They do have the same number of electrons, 24 and 24, so A is already the answer. Same number of protons, impossible, because they are different elements. One is Fe, one is cobalt, so cannot be. Same number of protons already is wrong because already different elements, so C and D are automatically out. Same number of neutrons, you can calculate the difference between the nucleon number and the proton number. Do that on the calculator. These are different, they are not the same there, so B is also wrong. Question number 7, we know about chlorine having 2 isotopes. We also know this particular case study, chlorine 35, you have a bit more of chlorine 35 and you have around 3 times more chlorine 35 than chlorine 37, and this is a specific case study where you can calculate the AR 35 times 3 plus 37 times 1, and then you divide the whole thing by 3 plus 1, and you will get 35.5. Relative atomic mass, as shown in the periodic table, is defined in the syllabus as the average mass for all the isotopes of the element relative to 1 over 12 times the mass of one atom of carbon-12. This is also stated in the syllabus as a definition that you have got to know. Well, we are using these isotopes. They are only carbon-12 and hydrogen-1. We're looking at how many different relative molecular masses. So we are thinking about summing up all the relative atomic mass. So you could have C2H3. These have no difference at all. Now we think about the possible combination. You have 3 chlorine, 3 times chlorine. You could have 35, 35, 35. You could have 35, 35, 37. You could change the order, 35, 37, 35, 37, 35, 35, but you will still have 2 35 and 1 37. When you add up 35 plus 35 plus 35, you're going to get 105. This is 35 plus 35 plus 35 because we are dealing with mass numbers. So 35 plus 35 plus 37 give me 107. We want how many different relative molecular masses? You could have 35, 37, 37, and this will give you 109. And I do believe that the last one is all of them being 37, so I can just move that up there. Seems like something is wrong there. What is wrong? Nope, that looks all right. And the other one must be 37, 37, and 37, and there'll be 111. So altogether, you only get 4 different mass combinations because this is all 35, this is all 37. You can have 235 and 137, or 135 and 237, and then these are systematic orders. There should be 4 lines in the molecular ion peak near the highest relative molecular mass region for the whole molecule. As a result, having 3 chlorines, you can have different combinations of the masses of the 3 chlorines, but for the carbon and hydrogen, they're all just carbon 12 and hydrogen 1. That's what I meant by no difference there. Question 8. Which statement about the substances at room temperature and pressure, that's 25 degrees Celsius, 1 atm pressure, these are unit of pressure, we're looking at correct. So this thing here is called ethanol. If you don't know this, well, you can see in the syllabus say draw dot and cross of methanol. This is ethanol. So it's kind of similar family. Each of these is a covalent bond, but they are not continuous. This is one whole molecule. So between the molecule, you have weak intermolecular forces. So what do we know? These are going to be simple covalent structure. This is diamond, as all of them are the same atoms, which is carbon. This is a giant covalent structure, and we know that diamond does not conduct electricity whatsoever. These are your cations, whereas these are your anions. All the electrons in the outer shell of lithium have been transferred to the outer shell electrons of the chlorines, the nonmetals. Now that you have no free ions, no free electrons, these ions are held in a fixed position. Okay, so no free ions because the ions are in a fixed position in a solid state because they are held tightly in a fixed position, only vibrating about their fixed position, so cannot conduct electricity. So when they say W and X can conduct electricity, we know that X cannot conduct electricity. These are basically alloy. Alloys are basically mixture of metals. So individually, metals can conduct electricity because they still have free electrons. You delocalize your outer shell electrons in order to give you the metallic structure. Giant metallic structure consists of cations, but these are cations of different sizes. Electrons don't have a size at all because you no longer have the shell, as you already delocalize, as stated in the syllabus under giant metallic structure, metallic bonding. So W can conduct, X cannot conduct, A is wrong. W and Y are elements, not W. W is a mixture of metals, and therefore there is an alloy. X and Z dissolve in water, so this is to do with lithium chloride. Most ionic compound can dissolve in water. You can think about solubility rules of chloride, and Z is basically ethanol. Ethanol is dissolved in water to give you alcoholic drinks and also disinfectant, for example. And then Y and Z have low melting point, not diamond, because diamond have very, very high melting point, whereas Z is correct because Z has simple covalent molecules existing as individual single molecule there. Question number 9. A piece of magnesium reacts with dilute hydrochloric acid. This is a metal. This is your acid. Metal reacts with acid, giving you salt and water. So Mg plus HCl. The salt that you're going to get will be a chloride. You call it magnesium chloride. And then when we think about formula of ionic compounds, we think about the valency. 2 and 1 is based on the charges of the ions. When we crisscross the valency, therefore it means how many of these Mg2 plus, well, 1 of it, and 2 of the Cl minus. such that you get MgCl2 formulation stated in the year 9 syllabus. Also, this general equation, metal plus acid giving you salt and hydrogen gas. This is one of the way to produce hydrogen gas in the lab, and you have tested for hydrogen gas using a lighted splint during a practical session in your alternative to practical as well, and the lighted splint will burn with a pop sound. Any equation you write have to be balanced, so there's 2 HCl there. This resulting solution is evaporated, so totally dry, you get solid residue of magnesium chloride. Which statement is correct? Covalent solid, that is wrong. MgCl2 between a metal and a non-metal, so you would draw the dot and cross of ions, not of molecules. That is wrong. Each chlorine atom gains 1 electron. That is correct, because each chlorine is already 2h7, and when you gain 1 electrons, you can get to a completely filled outer shell. But then we also know that each magnesium can give away 2 electrons, but each chlorine atom can only accept 1. That's why you need 2 chlorine atoms forming 2 Cl- in order to balance out the charges. LCM, lowest common multiple, primary school mathematics, and in chemistry we talk about balancing out the charges because the ionic compound have no overall charge. Each magnesium atom loses 2 electrons in the whole process. Molecules of an element, molecule is wrong, element is wrong, because you get compound, you also get ionic compound. Question 10, we have carbon dioxide. So carbon dioxide is CO2 from the case study. The dot and cross of carbon dioxide is stated in the syllabus under covalent bonding, simple covalent structure, under dot and cross. Carbon with 2 4, they want to share 4 electrons with another non-metal, and since we are using oxygen here, oxygen can bond with metals, but carbon is a non-metal, so we talk about sharing 2 electrons in order to complete the outer shell. So carbon and oxygen will have 4 and 2. These are basically what you call the valency. Valency is your combining power. In this case, it's the combining power of the atoms. It's the same way we use to construct formula in ionic compounds, 2 and 4, but these are not simplest whole number ratio, so can be divided by 2 on both sides, such that you get CO2 formulation. Well, we know that a carbon will form a double covalent bond with oxygen, and oxygen only share 2 out of 6 outer shell electrons. We don't care about the inner shell, only outer shell electrons are shown as usual in a dot and cross. We only use 2 out of 6. We still have 4 more on each oxygen. So we can see that here this is wrong because there's 6 more there, and D is wrong. What else? Well, I can tell you that A is wrong because there's 6 more there. Oxygen is group 6 with 6 outer shell electrons, not group 7 after all. And therefore this leaves the only answer as C there. Question 11, we have 2 statements about structure and properties of metals. We know that in metals we would have cations, so we have layers of cations. Layers of cations. The cations are of the same sizes because they are all of the same, they are from the same atom, right? In an element, this is metal. Metal are elements, unless you have a mixture of metals. Then this is cations, and this is your C of delocalized. Outer shell electrons. Outer shell electrons is also known as valence electrons. They are malleable because they have layers of cations, and it's stated in the syllabus, these layers of cations, they are of the same sizes. Since they are of the same size, they can slide over each other easily. Easily, and that is what makes them malleable. They have high melting point. Most metals do that, and that is a result of the strong metallic bond, and we have giant metallic structure. So most metals will have high melting point due to the strong metallic bonds that you need to break as a result of the giant metallic structure, the strong electrostatic force of attraction between the positively charged cations and the negatively charged electrons, the delocalized valence electrons, as stated in the syllabus. Mobile electrons, so you have free electrons because these electrons are no longer in shells, therefore they can conduct electricity. So both of these are correct statements, but none of them explain each other. Melting point is to do with structure and you need to break strong metallic bond. Malleable is to do with the layers of cations of the same sizes being able to slide over each other. But this thing explains conductivity. It doesn't explain malleable property. It doesn't explain high melting point. So both statements are correct. And statement 2 explains statement 1 that is wrong, does not explain statement 1. So B is the best answer there. Question 12. How many different elements are present in ammonium nitrate? This is an ammonium ion. Ammonium ion is one of the cation that you test for in the practical qualitative analysis. We also have nitrate, is another ion that you test for in the qualitative analysis. So if you think about the formulation, positive 1 and negative 1, these are your valency based on the charges of the ion is just 1 and 1, and therefore you can clearly see that how many of each ions are needed to give you the formula NH4 ammonium ion NO3, simply because the plus 1 cancel the minus 1 ionic compounds. It has a giant ionic structure with strong ionic bond between the oppositely charged ions. Although within the NH4 plus is covalent bond, although within the NO3 minus is covalent bond, but between them two it's ionic bond. So how many different elements do we have? We have nitrogen. Well, if I just count the atoms, because nitrogen exists as diatomic molecule as an element, if I just count the atoms, these are 2 nitrogen, hydrogen, and also oxygen. So there are 3 different elements there. Question 13, aqueous calcium hydroxide is an alkali. An alkali is basically what you call a soluble base. A base basically contains hydroxide ions. So calcium from a group 2, Ca2 plus, OH minus. We know about the formulation is one of the trickiest things that students always mess up with, because they know about hydroxide, they know about group 2 cations because they lose 2 outer shell electrons. As they have 2 outer shell electrons, we crisscross in order to work out how many of the ions we have. These are in the simplest whole number ratio already, so 2 of the OH minus, and as a result, people always write like this, which is wrong, because you have 2 oxygen and you have 2 hydrogen, so we write as a bracket OH twice. This is calcium hydroxide. Now we are neutralized. Neutralization is a reaction between acid and base to give you salt and water. So this is the salt that you get from nitric acid. It's called calcium nitrate, calcium 2 plus, NO3 minus, calcium nitrate like this. But we also know that all nitrates are soluble. This is part of the solubility rules. All nitrates are soluble, and as a result of it, in our ionic equation, this thing will be spectator ion. So nitrate is definitely spectator ions. And as for the calcium 2 plus, that is a wrong formula. First of all, this is wrong formula. And if I look at the second one, this is soluble, so that is wrong. And if I look at the third one, again, this is also wrong because it's soluble, so remove spectator ions. Ionic equation is a year 9 concept. Don't include the spectator ions, so that means A, B, and C are out, leaving only D, which is neutralization. Ionic equations, once you have been told it's neutralization, there can only be one ionic equation. H plus from the acid. Acid give you H plus, the base or the alkali give you OH minus. You don't get the salt there, it's just water formed there. Question 14, relative molecular mass of liquid Z is 60. And so the MR of liquid Z is 60. So if I see this, if I see the molecular formula, this is the actual number of atoms in one single molecule. This is as stated in the syllabus as part of the definition of empirical and molecular formula. So if I work out the MR of CH2O, that is 12 plus 2 times 1 plus 16. And I get 30 not 60, but the MR of liquid Z is 60, so this is already wrong. And these three are the same. No, these three are not the same, so let me just double check. This is H4 and H4, this is H6. I will just double check the one with the H4 first, and this is 12 times 2 plus, well, essentially it must be 2 times multiple of it, because, well, there's 30 times 2 give you 60, so 2 times carbon, 2 times hydrogen, 2 times oxygen. This definitely will give me 60, which means it's not D, it has got to be this B or C that will give me 60. And this is the, oops, this is the MR of Z, therefore D must be out based on the MR is not 60 there. Now, based on the idea here, 40% carbon, 6.7 hydrogen, and 53.3 oxygen, you can work out empirical formula. This is multiple choice questions. You'll be wasting your time once we already work out the molecular formula based on the MR, because you know definition of empirical formula, this must be wrong, because empirical formula, simplest whole number ratio of atoms or ions present in the compound or in the substance, so so cannot be this without simplified whole number ratio of the atoms there. So B is the only possible answer without me having to do the empirical formula at all. Question 15, you want to produce 27 tons of aluminium from aluminium oxide. Okay, so produce means to make, so that means you want aluminium on the right side. Aluminium is a metal, so this is Al2O3 because it exists as a compound. So aluminium coming from Al2O3, the other product will be O2. Balancing the equation, 2 aluminium there give me 2 aluminium, and I can get 3 over 2 because 3 over 2 times 2 is 3. That is normal primary school mathematics. We're not interested in the oxygen, we're interested in the Al2O3 and the aluminium there. So they want it in tons because this is making tons. So the tons will come from the tons. These are to do with reacting masses. So in order to do these questions, I really need to work out the MR first of all. So MR is always for 1 unit. We are looking at gram per mole. So that is 27 times 2 for the 2 aluminium, plus 16 times 3 for the 3 oxygen, so that is 102. And then the MR for aluminium, again this is for 1 unit, only. Straight from the periodic table, there's just 27. So you can do it step by step, but I'm just going to do all in one. So this is the mole of Al2O3 is to the mole of aluminium. From the balance equation, the Al2O3 is 1 mole. 1 mole of Al2O3 comes from, will produce 2 moles of aluminium. On the far right, on the top is to do with the mole of Al2O3. The mole of Al2O3, I want the mass. So this is the mass of Al2O3 divided by the MR, so 102. And at the bottom, I have 27 tons of aluminium divided by 27. Bring up the denominator. Half times 27 over 27 equal to the mass of Al2O3 over 102. You can bring up the 102 to the other side as well. Can do it step by step. Since I've moved up the times 102, I must remove the other one because this is normal mathematics and you have to do it properly. Now pressing your calculator, you will see that there's just 102 times a half times 27 over 27, which give you 51 tons there. So there's step 2 there. Well, step 3 actually. Continuation from step 2 up there, going to that, working, giving us 51 tons of aluminium oxide that is needed to give me 27 tons of aluminium. Question 16, these are about proton number. Nucleon number is basically the number of protons and the number of neutrons. So the number of protons plus the number of neutrons. So to work out the number of neutrons, you just have to, take away the proton number. So these are the same proton number. So since they have the same proton number, they are the same element, but the atomic structure is different. Same number of protons, different nucleon number would mean that different nucleon number would mean that even though they are the same elements, but they have different atomic structure, different number of neutrons there. So there are different atoms of the same element. and therefore W and X are isotopes, same number of protons, different number of neutrons, or different nucleon number. One is correct. Now Y is in group 5. This is group 5Y. Is it? Well, let's have a look at the electronic configurations. So for Y, the first shell is only 2 electrons. So if you have 7 electrons, you are left with 5. So this is your second shell. This is your outermost shell. So therefore it's group 5. That is correct. And then Z is a cation. Cation basically means positive ions. Whether you are positive ion or not, count the number of protons. So you have 8 protons, but you have 10 electrons. So atom gains 2 electrons. E minus, the charge of electrons E minus. It is not a cation. It is an ion instead, because it is a 2 minus charge. So only 1 and 2 are correct there. Question 17, compound X is sodium iodide. We know that, what do we want? All sodium salts can conduct electricity. All sodium salts are soluble in water. And if they are soluble in water, you will get aqueous ions, you will get free ions in aqueous solutions, as we have this component here in aqueous solution. Methyl methanoate, if you draw it out, hydrogen form 1 covalent bond, carbon form 2 covalent bond to the oxygen, but there is another oxygen, and you can draw dot and cross from these. Carbon form 4 bond, 1, 2, 3, and 4. Hydrogen form single covalent bond. Oxygen form 2 covalent bond. Oxygen form 2 covalent bond. And carbon form 4 bond there again. So this is a simple covalent structure or simple covalent molecule. It cannot conduct electricity because it exists as molecule, and then there is no free electrons at all, as it is not even ionic. So at room temperature and pressure, something are solid. This is going to be a liquid, as it has law liquid, or in fact you can think of it as a gas if you want to, but I know it's a liquid. So it has law melting point and boiling point as a result of the simple covalent structure. Whereas X is a ionic compound, giant ionic structure, strong electrostatic force of attraction, strong ionic bond between Na plus and I minus, metal and non-metal there. So in terms of conduction, only X can conduct, the molecule cannot conduct there. So D must be the correct answer there. Question 18, this is to do with solubility rules. So they will not ask you, directly what are rule number 1, what are rules number 2. This is about a white compound insoluble in water. We know that all sodium salt, potassium salt, and ammonium salts are soluble. If you contain these ions, these cations, then you are soluble. So sodium salt insoluble, it cannot be because this is insoluble. So sodium salt Na plus cannot be present. So Na plus not present. So A and B are out. We also know that for the anions, all nitrate salts are soluble. So if you contain nitrate, it will be soluble, but this is insoluble, so cannot contain nitrate. So must be B, or, well, in fact we got an answer already because A and B was crossed out from there, and then we cross out D from there. Nitrate cannot be present for it to be insoluble, so must be C there. And we know calcium carbonate. So this compound is calcium carbonate, Ca2 plus, CO3 2 minus, 2 plus cancel 2 minus. Even if we do the crisscross and cross multiply, you need to get to the lowest common multiple. That was in chemical formula in year 9. Calcium carbonate, solubility of carbonate. All carbonate are insoluble except for sodium carbonate, potassium carbonate, ammonium carbonate. Question 19, we have lead sulfate. This is to do with solubility of sulfate. We know that all sulfates are soluble except for 3 in the syllabus, except for lead 2 sulfate, Pb2 plus, SO4 2 minus, 2 plus cancel 2 minus, PbSO4. You also have barium sulfate. Test for sulfate using barium nitrate or barium chloride solution, and then you will get a white precipitate. Also, calcium sulfate is not soluble. So the lead sulfate form is a precipitate. So this is insoluble white precipitate, and how do you separate it from the mixture? Well, how do you make it in the first place? Because they are insoluble, so therefore you do it by precipitation method to prepare this particular salt. And we don't want lead chloride because these are insoluble, whereas precipitation is basically aqueous plus aqueous giving us precipitate. That is the idea in precipitation. So all nitrates are soluble, as we talked about it in the previous question, solubility rules. All nitrates are soluble. And we can think about the other thing, which is the same. All potassium salt, sodium salt, as well as ammonium salt are always soluble. So, all K plus salts are soluble. And we are precipitating out insoluble stuff. They didn't tell us the solubility. We just need to know solubility rules. And it has to be filtration because insoluble precipitate, whereas crystallization is for something which is soluble salt. So this question only has one answer, which is option D there. Question 20. Some reactions of an aqueous solution of compound X are given. When you have a few drops of aqueous sodium hydroxide, you get a white precipitate. So this is few drops aqueous sodium hydroxide. And then when you add nitric acid and you warm it, a gas is formed. So this gas decolorizes acidified manganese 7, so that goes from purple to colorless. What is the gas? So we can say test for gas, the gas is SO2, but what is the ion present? Because you added acid to it, only then you get SO2. So the ion is sulfite, SULFITE, SO3 2 minus. When I use dilute nitric acid and barium nitrate, no visible reaction. That is the test for sulfate. So therefore, we can say no sulfate. No sulfate, since no visible reaction. So sulfate there, that is wrong. It contains sulfate. Obviously, A is wrong. And in terms of cation is to do with the sodium hydroxide test, but be very careful. Few drops. Not excess. So which one give you white precipitate when you add a few drops? Could be calcium 2 plus. Yes, calcium 2 plus is possible. Could it be Al3 plus? Yes, we know aluminum hydroxide is soluble in excess sodium hydroxide. They did not mention excess. Zinc hydroxide also possible because that is soluble in excess. The hydroxide of Al3 plus and Zn2 plus is soluble in excess sodium hydroxide. They are not soluble when you just add 1 or 2 drops. So it could be either Al3 plus or Ca2 plus or Zn2 plus. It has to be sulfide. There are 3 possibilities for the cations as stated in the syllabus and also the Q8 table, which is not given in the theory paper. Question 21, which statement is correct? Mixture of liquids with boiling point. Different boiling point. If you have different boiling point, you can do distillation, so A is already correct. But if we look through the other options, locating agent is not for colors because it's for colorless spot. Things like amino acid, if they are colorless, cannot see. If you cannot see, that means you need locating agent. If you already have colors in ink, you can see it, you don't need locating agent. Desalination of seawater is not going to be fractional, it's going to be simple because it is just separate salt from water. So you're collecting the distilled water from the salt. There's just one component. You don't need fractional distillation because you just have one component, which is the water coming out. So desalination basically means remove the salt from seawater, and you get the drinking water from the sea. RF value is not, it's got this the other way around because it's the distance moved by the solute over the distance moved by the solvent from the baseline to the solvent front. So D is wrong, A is the only correct answer there. Question 22. So we have atomic structure. So we know that this is proton number or atomic number. It tells us the number of protons, whereas this 14 is your nucleon or your mass number is basically the heavy stuff in the nucleus, the number of protons plus the number of neutrons. So protons, you have 6. Electrons, you have 6 because this is atom. There is no charge. If there is an ion, it will have a charge. And therefore, the number of electrons equal the number of protons as the plus 6 cancel minus 6. And then the neutron is going to be 14 minus 6, which is 8 neutron. So which statement about an atom of element X? It has 6 electrons, yes, because we're talking about atom. 8 protons is wrong. It has 6 protons. It is an isotope of carbon. Well, carbon will be 6, and this is element number 6, yes. And the usual carbon is carbon 12. This is the reference standard. This is for the relative atomic mass as stated in the periodic table, as stated in the syllabus. All your relative atomic mass is relative to the mass of one atom of carbon 12, and you multiply it by 1 over 12. So it is an isotope of carbon, it has 6 electrons. It's an isotope of nitrogen? No, because the proton number of nitrogen is 7. So 2 and 4 are wrong, only 1 and 3 are correct. Question 23, greatest mass of solute. Greatest mass of solute. So we have given volume of solution, not gas. By the way, these are volume of solution. We are given concentration. Okay, so we have mole equal to mass in gram over gram per mole. So what I can do is I can divide both sides by dm cube, and what I will get then is if I divide both sides by dm cube, so left side divided by dm cube, right side divided by dm cube, the greatest mass of solute will have the greatest mass in 1 dm cube. So really what I do from there to there is divide both sides by dm cube, and that is normal mathematics. Mole over dm cube, which is concentration as given, multiplied by gram over mole will give us gram per dm cube. Is that correct? We could do that, but I don't think that is the best way to go around it. So perhaps that is not going to be useful, because I think we might have to work out the mole first, and from the mole of the substance, then we work out the mass present with the MR. Okay, so that's probably the best way to go, I think. So let's just do that. Let's do for A. So the mole of sodium hydroxide is going to be CV, so N equal to C times V. That is in mole per dm cube. The V must be in dm cube. So if I just sub it in now, so 100 times 10 to the minus 3, this is for the volume in cm cube, times 10 to the minus 3 is exp minus 3 on your calculator to convert the 100 cm cube into dm cube. 100 divided by 1000, mathematics standard form, 100 times 10 to the minus 3 is the same as 100 divided by 1000, multiply by 1.00 mole per dm cube, and I get 0.1 mole. And this is sodium hydroxide, so N equal to mass over mR, so the mass is going to be N times mR, so this is 0.1 times sodium hydroxide mR is going to be 23 plus 16 plus 1, so that is going to be 40. Oops, nope, I don't want that. Times 40, so 0.1 times 40, this gives me 4 gram. So there is 4 gram in there. And we're going to work out for each and every one. It seems a bit tedious, but should be able to. So the MR of H2SO4, I think probably just write the MR on top there. So there's 40. And then the MR of H2SO4, 2 times 1 plus 32 plus 16 times 4. So there's 98. The MR of KOH, 39 plus 16 plus 1. So there's 56. And then the MR of HCl, 1 plus 35.5 is 36.5. So for B, what you have is 500. So you have the mole of sulfuric acid equal to 500 times 10 to the minus 3, convert to dm cube, multiply by the concentration. And you get 0.025 mole. And in order to work out the mass, so therefore the mass of H2SO4 is going to be the mole multiplied by the MR is what we had done previously. The mole multiplied by the MR. So 0.025 moles times 98. And you get 2.45 mole, so 2.45 gram. Now I run out of space for these, but you should be able to write anyway. If I just do the calculation, 1 dm cubed times 0.1 is 1 mole. 1 mole times 56, this gives me 5.6 gram. And last but not least, I have 2 dm cubed, so 2 dm cubed, no need to convert anymore, times 0.01. I get 0.02 mole, multiplied by 36.5. I get 0.73 gram. You want the greatest mass of your solute, so there's got to be option A there. Question 24, this is to do with rate of diffusion, and you want the gas that diffuses faster and the temperature at which it's most rapid. So this one is faster. In terms of temperature, it's higher because higher temperature means greater kinetic energy. Your particle would gain more speed and therefore they will be able to diffuse faster. In terms of the gas that will diffuse faster, it will be the lighter molecule, because the lighter you are, the faster you can diffuse. So look for the one with the lower MR. If I just work out the MR of CO2, carbon dioxide, as stated in the syllabus, the formula. So there is 12 plus 16 times 2, that is 44, versus the MR of CH4 is again stated in the syllabus. Methane is stated in the structure and bonding under the dot and cross for covalent molecules. Carbon dioxide is also stated in the dot and cross for covalent molecules. So this is 12 plus 4 times 1 is 16. So the one which is going to be faster is the lighter one. It's going to be methane that will diffuse faster at a higher temperature. Question 25, which statement about atoms and ions is correct? Now, atoms and ions of the same element must have different number of neutrons. Must have, must is wrong, could have. Okay, they could have, but not necessarily they must have. Isotopes of different elements. So usually we say isotopes of the same element, but this one is different elements. This is usually isotopes of same element. So they must have different number. Could have, there's again could have, all right? So if they have different number of neutrons, it's just a possibility. C looks complicated. How about D? The number of protons and number of neutrons in an atom must be the same. Must be, again, must be is wrong, could be the same. Okay, because things about hydrogen, 1, 1. So there is 1 proton, but there is 0 neutrons. So, you know, it's not necessarily the same. But then when you have carbon 12, so you have 6 protons, but you also have 12 minus 6, which is 6 electrons. So it could be the same, but it could also be different. So D is also wrong. C must be correct. Let's have a look at the positive ions. If we have positive ions, so that means the atom loses electrons. If you have nucleon number minus the number of neutrons, this will give you the number of protons. If you consider nucleon number minus the number of neutrons, this is basically the number of protons. If you lose electrons, you will have lesser electrons than protons. So if you lose 1 electron, so this will be bigger than the electrons number by 1, and therefore you will have a positive 1 charge. So this is entirely correct. It's just making it a bit more complicated. Question 26. When you heat this compound with an aqueous solution of compound Y, produce a gas that turns red litmus paper blue when you heat it. So we can think about this being an alkaline gas, and this is the test for ammonia gas. How in the world do you produce ammonia in the lab? Well, you think about what you did in qualitative analysis. This is aqueous hydroxide. You normally use sodium hydroxide, but this is your OH minus, and you must react it with ammonium salt, so NH4 plus. Whatever that has NH4 plus will react with anything that contains hydroxide. Okay, this is your 5th general equation in year 9. Ammonium salt plus any hydroxide, metal hydroxide, give you metal salt, ammonia, and also water. I'm writing the ionic equation. The the NH4 plus will loses the H plus and is acting as an acid, whereas the OH minus will accepts, or it will gain the H plus and will form water, and NH4 plus loses H plus and you get ammonia as a gas, and this is ionic equation in year 9 chemistry. Ionic equation is an important component of your syllabus. Okay, so we gotta think about what this is now. Y could be potassium hydroxide, yes, because it contains hydroxide ion. So that is correct. Doesn't need to be sodium hydroxide because even potassium stuff are soluble. X is an acid. X is an acid. Acid reacts with hydroxide, give you water. So if X is an acid, then you would just get water. This would be neutralization and you would have no ammonia. No ammonia. So we get ammonia gas, so cannot be an acid. It could be an ammonium salt, yes. X could be sodium nitrate, no, because these are not tests for nitrate. For nitrate, we need to add aluminium foil as a solid. And together with the sodium hydroxide, only then you produce as the ammonia gas. So only 1 and 3 are correct there. Question 27, aqueous solution of zinc chloride. Zinc chloride. So which observation is correct? So you have zinc 2 plus aqueous cation. You have zinc chloride, so it's Cl minus, ZnCl2 aqueous. So we know barium nitrate is test for sulfate. We have no sulfate at all. So white precipitate is wrong because no sulfate is present. Aqueous ammonia. So we could test for Zn2 plus aqueous. White precipitate, soluble in excess. This is correct. Zn2 plus is present. So we should probably check through the rest and make sure that we are not wrong. This is insoluble in excess is wrong because ZnOH twice, solid. White PPT, this is soluble in excess of NaOH. Whenever we write, we always try to write excess of what, so that we remember what it is. Powdered copper, that will not work, and you will learn more about this in the reactivity topic of metals in year 10. So this is more in year 10 reactivity of metals, but then you could have gotten the correct answer by knowing the qualitative analysis table results already without even eliminating this thing, which is impossible. Question 28, relative atomic mass is to do with the average mass of all the isotopes of an element relative to the mass of one atom of carbon-12 multiplied by 1/12. Or this is relative to 1/12 of the mass of one atom of carbon-12. This is in the year 9 syllabus of the curriculum, how to define relative atomic mass. So we know that chlorine as a gas is diatomic molecules, as they would use 1 out of 7 outer shell electrons to form a covalent bond, and you still have 6 electrons in the outer shell. So the MR of Cl2 is 35.5 times 2, which is 71. This is called 71 gram per mole. So this is 71 gram in 1 mole of chlorine gas. So therefore, 2 mole is 71 grams times 2, which is 142 gram for 2 mole of chlorine gas. 29. Methane burns in oxygen. This is called combustion. These are gas, 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 and liquid, so not gas. So we're going to think about reacting volumes of gases. So instead of reacting masses, we have reacting volumes of gases, where we have to think about the molar volume of a gas. And this is to do with 24 dm cube for 1 mole of any gas, as stated in at the bottom of the periodic table at room temperature and pressure. So if we have 10 cm cube of methane, so 10 cm cube of methane, and we put in 25 cm cube, this is what you put in. But when you think about reacted based on the reacting amount, 1 mole reacts with 2 mole. So that means 1 mole of a gas is 24 dm cube, will react with 2 mole, which is 48 dm cube. So if you have 10 cm cube, you should only react 20 cm cube, because if this is 10, then this is 10 times 2, which is 20 cm cube reacted. So what are you going to be left behind? So if we think about what is left behind, so left behind, this one will be 0. 25 is what you put in. 20 is how much reacted with 10 cm cube of CH4. So 25 minus 20, you're left with 5 cm cube of O2. This is unreacted. But then we are also having the product where 1 mole CH4 give you 1 mole CO2. So 10 cm cube of CH4 reacted should give you 10 cm cube of CO2 as well. As a result of it, how much volume of gas they will be measured after the reaction. This is liquid, this is not a gas, therefore the gas remaining will be 5 cm cube unreacted oxygen and 10 cm cube CO2. So that is 5 plus 10, this is for the O2, this is for the CO2, so you get 15 cm cube there. Question 30, we have chromatography. So in this chromatography experiment, we are supposed to find the RF value of Fe3+. And to make it more visible, because iron 3 plus aqueous is not a precipitate, it's just, well, kind of like yellowy solution, but to make it more visible, you can spray it with like this locating agent to make it a precipitate, reddish brown precipitate, as you would know from qualitative analysis. Topic on the formation of iron 3 hydroxide. So it must be a red brown color, and the RF value is to do with the distance moved by the solute relative to the distance moved by the solvent. So the RF of the iron 3 plus is how much has the iron 3 plus spot moved from the baseline. The starting line is called the baseline, BASELINE, to the solvent, and then the distance moved by the solvent to the solvent front. So X over Y is what we're looking for, not Y over X, as RF is a ratio between 0 and 1 there. Question 31. So gas X has the following properties. So this is colorless, cannot be chlorine. Chlorine is colored. Chlorine has very, very pale green color. And there's the first thing we can spot that, based on property number 1. No effect on red or blue litmus paper. So that means not alkaline, not basic, not acidic. So when we look at this, ammonia is alkaline, or you can think about it being a basic gas, so therefore we can cross out ammonia. Between hydrogen and oxygen, we know both of them has no effect on lime water, because this is the test for carbon dioxide. Last but not least, we have this thing which is flammable. So oxygen support combustion. You definitely need oxygen in order to burn. Like hydrogen can only burn if you have oxygen, but oxygen is what we are breathing in. The oxygen itself is not flammable, it supports combustion. It is hydrogen that is flammable. Hydrogen plus oxygen. Lower secondary sciences, where gaseous hydrogen burns in gaseous oxygen to give you liquid water, and this one will give out a lot of energy. You will feel the heat, and this is the test for hydrogen. You use a burning splint or a lighted splint, and the splint itself is the flame and burns in the oxygen to give you a pop sound, but the fire will not keep on burning because water will put out fire. Question 32, we have aqueous solution, colorless solution. It has cations and it has Cl-. Now you get a white precipitate with a few drops of aqueous sodium hydroxide. So be very careful. This is few drops and it is also few drops. So we're looking at which one is correct. So the cation must be Al3+, but could also be calcium 2+, which give you a white precipitate with sodium hydroxide, although not really with ammonia. So could also be Zn2+, for instance, or Al3+. So not necessarily must be, could be. Okay. Now this is white precipitate. So this one, it will give you a colored precipitate. In fact, iron 2 hydroxide iron 2 hydroxide Fe2 plus OH twice is a green precipitate that will turn brown on standing. And so, cannot be B. When you add in dilute nitric acid first and then you add in barium nitrate, this is the test for sulfate, and you get a white precipitate. So this one we can say it's not sulfate, it is chloride if you read the question. So C is wrong. And D, this is the test with aqueous silver nitrate. After you add in acid first, then you add in solution of silver nitrate, you get a white precipitate. This is the precipitation reaction of insoluble silver chloride precipitate. It's a classic ionic equation based on the solubility rules, and therefore D must be the only correct answer there. Question 33, we have an impure sample. So impure sample will not have a fixed melting point. So not fixed melting point because it is impure substance. Only pure substance has a fixed melting and boiling point. X is purified and its melting point is measured again. So how do you purify it? Let's see. Can you crystallize it? Crystallization only works to get it from soluble solution, right? If the stuff is soluble in water, soluble in the solvent, and then distillation is to collect liquid. Distillation is to collect liquid, and if I think about this is going to collect liquid. But then you have impure sample of compound X. This is 120 degrees Celsius. This is above 100 degrees Celsius. Okay, so this one is not going to be a liquid at room temperature and pressure. Not liquid at 25 degrees Celsius. If it is not liquid at 25 degrees Celsius, it can be quite difficult to boil. And besides, this is melting. This is not boiling. If it is boiling, then yes. If your melting point is already that high, that means it's going to be much higher temperature in order to boil. So, it's not going to be practical for distillation. Has to be crystallization as a result of that. In terms of the melting point, now this melting point is lower, this melting point is higher. What do we know about impurities? So the idea about impurities is that impurity raise boiling point. Think about salt, adding salt to boiling water before you boil your pasta, the pasta that we eat. So you make the water boil at high temperature. But we also know that impurities lower melting point. So this 120 degrees Celsius is lower than what it should be. So 120 degrees Celsius is lower than actual melting point. So based on that information, when you have the pure X, the actual melting point should be a little bit higher. Therefore, leaving C as the only possible answer there, where in the presence of impurity, the melting point is a bit lower. These are very high melting point, boiling point is a lot higher, only crystallization is suitable to get it out from the whatever solvent you dissolve it in. Question 34, we have these 3 nitrogen compounds. We know ammonia from our case study. We don't really know the other 2, but this must be simple covalent molecule. Which compound has the highest MR? Well, if you look at the MR, you can calculate for each and every one of these. So MR of N2H4, so there will be 12 times 2 plus 4 times 1. So that is 24 plus 4, that is 28. And then the MR of NH2OH, there's 14 times 1 plus 3 times 1 because you have 3 oxygen, 2 there and 1 there, plus 16, so there's 33. So the highest, the MR will be NH2OH and not the N2H form. Now you want the greatest percentage by mass of hydrogen. This is stated in the mole calculation topic. This is to do with the mass distribution. So we already crossed out A, so A cannot be the answer anymore. So we're not looking at A and B, we're just looking at NH3 versus N2H form. We haven't calculated MR of NH3 yet, so there's 14 plus 3 times 1 is 17. So the percentage, you want the percentage by mass of nitrogen. Out of the whole 17, you have 1 nitrogen. Each nitrogen has a mass of 14 out of 17, and I have to convert that into percentage. that is probably going to be quite high. It's 82%, just to the nearest whole number. But then for N2H4, so the percentage of nitrogen is going to be out of 28. Am I correct? Nope, I think I've made a mistake. I definitely made a mistake. N2H4 is not 12 times 2, it's actually 14 times 2. See, it's very easy to make a mistake there. 14 times 2 plus 4, that gave me 32. So which one is higher? 33 is still higher than 32, so I think I'm okay there, luckily. All right, but then because I spotted that it was nitrogen and not carbon, would have messed up otherwise in the theory paper. So it's not out of 28, it's out of 32. So 2 nitrogen, and then 2 times 14, which is 28, divided by 32 times 100%, and I get 88%. The greatest percentage by mass of hydrogen is not in NH3, but in N2H4. So that must be option D there. Let me just move that up there a little bit. Question 35, use the periodic table. Which two particles have the same number of electrons? So these are atoms. Atoms are uncharged, and therefore the number of electrons equal to number of protons. These are different elements. If you have different element, then you have different proton number, therefore you have different number of electrons for the atoms. End of story. Na plus and K plus. So K plus, well, K is below sodium in the periodic table. So these are in group 1, Roman numerals stated in the periodic table. They are in group 1. Then you lose one outer shell electrons. So without even doing it, but if I do it, you should be able to see that I have lost the third shell for the Na+, I've lost the fourth shell for the Na+, definitely different number of electrons from the electronic configuration itself. Fe2 plus and Fe3 plus, these are same element. If they are the same element, the proton number is the same. So if the proton number is the same, but you have different charges, you are ions of the same element, therefore your number of electrons cannot be the same, leaving behind D as the only possible answer. Calcium lose the 2 outer shell electron. Scandium is the next element after calcium, you lose 3 outer shell electrons. Both of these would have argon, same configuration as argon, and D is the only possible answer. Question 36, you have a covalent compound. These are empirical formula, simplest whole number ratio of atoms. So we work out, this is 1 carbon, this is 2 hydrogen, and 2 oxygen. There is only 1 oxygen there, there is 2 oxygen there, so you know A is wrong. Carbon, 2 carbon, 1, 2, 3, 4 hydrogen, and 2 oxygen. I can simplify this to dividing by 2 across the whole thing. So C1H2O, so B must be our answer there. But if I look through the rest, I have C2H4O, so again that 2 and 4, but then this is only one, so you know you can't simplify that any further. So that is the empirical formula, which is not the same as whatever is given in the question there. Well, of course we already got answer as B. I'm just showing you why the rest are wrong. So this is C3H 1 2 3 4 5 6 O2, and you cannot simplify 3, 6 and 2 anymore. So what happened there is this is already the empirical formula, so C and D are definitely wrong. Question 37, which statement about states of matter is correct? So when a liquid freezes, it becomes a solid. When a liquid freezes, you have liquid going to solid. You don't need to break any bonds, but in fact you are forming new bonds. Essentially you will release energy to the surrounding because it will release energy, not needing the energy. If you want to melt, or if you want to boil, then you need to absorb energy in order to melt or to boil, because you need to break some stuff. So I think A is actually correct, but let's just go through B as well. Reaches its boiling point, you don't call that evaporation, you call it boiling, because evaporation can take place at any temperature. Boiling only at the boiling point. So B is wrong. When a solid changes directly to gas, you don't call it condensation, you call it sublimation. There are some stuff that will sublime. Think about carbon dioxide as a solid. You call it dry ice, and they will sublime all the way to carbon dioxide gas directly. That's what is present in some fire extinguisher. You call it powder CO2 inside those fire extinguisher. And you also have sublimation for iodine as a gray solid. It's sublime all the way to a purple gas directly if you heat solid iodine. When the solid melt, the particles get further apart. They have more energy. As we talk about, gas particles can move randomly at a high speed in all directions, and as such you are heating up the particles, and therefore it's a heating curve kind of thing. Therefore you will get more and more energy. So hang on, so D is wrong, so A must be the answer. Question 38, which separation method will give pure samples of both substances? So you want both substances. If you get copper sulfate crystals and water, crystallization, you get the crystals but not the water, because we still have the saturated solution, and that is why we filter and we wash, but we don't get the water. And therefore this method is not good. Ethanol and water, so they mix together, they mix well, they are miscible. So to separate ethanol and water, we need distillation. We need a simple distillation in order to separate out ethanol and water. Very, very common thing, not evaporation there. Salt and sand, so you could use filtration. And that's after you dissolve it in water. The salt dissolves in water, the sand is insoluble, so filtration is good. However, from the mixture, this is not salt solution. This question is a bit tricky. This is not salt solution, because if we look at the next one, fractional distillation is correct. From the liquid air, you can definitely separate out nitrogen and oxygen, and that is how we get the nitrogen in industry as well as oxygen in industry, because these gases have different boiling point, can separate them out. But salt, being a solid on its own, cannot be separated from sand by filtration, because the salt is the solid at the beginning. So unless you have salt solution and sand, then yes, you can get both substances by filtration, and then etc. etc. So the best answer there must be D and not C. So do not get tricked. This is a trick question. It's about reading as well. Question 39, we want the concentration in mole per dm cube. So first of all, we have been given the mass. So the MR is needed in order to convert mass to mole. So that is going to be 23 plus 16 plus 1. So that is 40. And the next thing will be find the mole of NaOH. So if I have the mass over the MR, so that's 3.4 over 40. So that will be the mole. And then if I want the concentration, we know that N equal to C times V. Therefore C equal to N over V. So I have 3.4 over 40. This is mole. And then I gotta divide this. I gotta divide this by the volume of the solution, which has 500 cm cube. We want in mole per dm cube, so I times 10 to the minus 3 in order to convert cm cube to dm cube. You could also do 500 divided by 1000. On calculator, this is 500 exp minus 3. Exp is the button next to your answer button on your calculator. This is called standard form. It is a secondary level mathematics. So this is 0.17 mole per dm cube there. Question 40, this is the last question in this 40 question MCQ section. So we have a metal carbonate reacting with acid, and they will give us carbon dioxide, water, and the salt. And we have 0.100 mole of hydrochloric acid. We have this much mole of sodium carbonate. You're given both the mole of carbonate, and you are also given the mole of the other reactant, which is the hydrochloric acid. Why in the world do they give you two information like this? Because before you do any calculations and work out what is the mole of carbon dioxide, which one is limiting and which one is in excess, because only the limiting reactant is completely used up. So how much product you expect to get must come from the mole of the limiting reactant. So we can say 1 mole Na2CO3, you need 2 mole HCl. So we already been told that this is 0.0800 mole of Na2CO3. How much mole do you need? You need twice as much. So pressing your calculator, 0.08 times 2, you need 0.16 mole of HCl needed. But what did we put in? We only put in 0.100 mole. But we only use 0.100 mole HCl, therefore not enough HCl. This is how you explain limiting versus excess in structured paper, and this is also what you must be doing before you do calculations like this, even in an MCQ. So HCl is limiting, so that means the sodium carbonate is excess. Having done that, we need to relate the mole of CO2 is to the mole of the HCl and not the mole of the sodium carbonate. Even though this was the first one given to us, we already established that HCl is completely used up. Therefore, we work out the mole of CO2 from the mole of the limiting reactant. 1 mole of CO2 comes from 2 mole of HCl. So 1 mole of CO2 comes from 2 mole of HCl. And then on the top, I want the volume. So this is to do with gas. So, molar volume of gas given at the bottom of the periodic table is 24 dm cube per mole of gas. And this is at room temperature and pressure, as the question did state at room temperature and pressure. So that is the volume of CO2. This would be in dm cube, as I'm dividing it by 24. And they also want it in dm cube. So if I keep it in dm cube, I divide by 24 dm cube per mole. That is the actual mole of CO2. And the actual mole of HCl that reacted, because HCl was limiting, you have 0.100 mole of HCl there. So there's already mole of HCl. This is the mole of CO2. These are the mole ratio from the balance equation. These are the label from which I, label it based on the equal sign there. So move up the numbers, and then I get volume of CO2 over 24. You can then move up the 24 to the other side, and you should be able to just press your calculator and you get the volume of CO2. This must be in dm cube based on what we had used in the formula earlier. So 0.5 times 0.1 times 24, I get 1.2 dm cube. So the volume of CO2 is 1.2 dm cube there. And that is 1.20 based on the accuracy in the questions, which was 3 significant figures. So 1, 2, and 3 significant figures based on the data, the significant figure in the question given. And that's it really, 40 questions in this year 9 end of year examination. Paper 1, multiple choice questions, pure chemistry, triple sciences curriculum, covering a few topics, including the mole calculations, atomic structures, states of matter, as well as experimental techniques and qualitative analysis. Thank you for watching. Don't forget to click the button on the bottom right on the video, and subscribe and share the channel widely with other people. If these are useful to you, perhaps it'll be useful to many other people as well. Thank you for watching, and do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. Thank you for watching again. I'll see you in the next tutorial video.